Hey students, we start a new unit today on conic sections. Now it's chapter 9 of your textbook, your electronic textbook, which starts about page 660. And this is actually a drawing from, a diagram from your textbook. We'll be primarily focusing on these four: the circle, the ellipse, parabola, hyperbola, not in that order. And while that's a really nice drawing, I prefer this one. It's more easily drawn, so please do put it in your notes. And to me, that's a little bit clearer than the one on the left. So let's start with circles. And beginning with the definition of the circle, of course, it's the set of points on the arc that are equidistant from the center. Circles are named for its center. So if this point right here in the middle was 3, 6, and that was point M, it's named for its center, whereas if you had a point on the arc that was identified, you don't name it by a point on the arc. So there's two forms that you're going to be working with, one being standard form of a circle and the other being general form. Now standard form looks like this. It's x minus h quantity squared plus y minus k quantity squared is equal to r squared. And the deal here is that the center is HK. And the one that I showed you right here where you had center 3, 6, if I were to make that equation, I would say x minus 3 quantity squared plus y minus 6 quantity squared equals, and I would have to find that radius and square it. It's actually fashioned after the Pythagorean theorem. And if I get time, I'll show you exactly how that works. But this, again, is standard form. I like to call it center radius form, same. So I'll write that for you, center radius, because it identifies your center and it gives you the radius. Now in general form, I want to give you an example of general form because I think the letters will just throw you off. It would look something like x squared plus y squared plus 6x minus 7y equals 12. Notice that it doesn't tell you the center or the radius, actually. It does, I guess, give you the y-intercept because it has a constant. But this one is one where we'll have to complete the square to find the center and the radius. The one on the left, by the way, well, both of them, please notice that the A is always the same. The same x will be for the same y. You're not going to have different one. You'll always be adding a positive x, positive y when it's in its correct form. And that way I know that I have a circle. So let's start with the most basic of the problems. If you were told to create the equation, to write the equation that is described here. So here I've written, state the equation of the described circle for number 2 and 3. You would, the center is at the origin, so that is, instead of saying x plus 0, y plus 0, you'd actually just say x squared plus y squared is equal to, but you're going to have to square this radius, and 4 times 4 is 16, times 2 is 32. So this is the answer to your number 2 right here. On number 3, given this center, the front part is easy. It's x minus 3 quantity squared, because you always denote negative hk in this equation. I guess I could have written x minus h quantity squared plus y minus k quantity squared equals r squared. Okay, back here, x minus 3 plus y minus 7 quantity squared is equal to, now to find your radius, you are actually going to have to find the distance between this point on the circle, because they're all equidistant to the center. So any point on the circle will do. So I'm going to use a distance formula. So the distance between 3 and 1, of course, is 2, correct? And I'm going to square it. And the difference between those two y's is 7, and I'm going to square that. So I get 4 plus 49, which is equal to the square root of 53 is a distance, but careful, you have to put r squared, so you just put down 53. So that is how you state the equation of the described circle. Now I'm given the general form of 18 and 19, and I'm asked to state the equation in standard form. Well, for number 18, I don't think you're going to have any problem because you just have to complete the square. I will remind you how to do that. First of all, you have to write this. You got to group the x's together and the y's together and move the constants. So I'm going to put x squared minus 10x plus, I don't know, plus y squared, and I'm going to use negative 6y, plus, I don't know, is equal to negative 25. So whenever you're completing the square, don't know if you remember how to do this, kind of how I do it, of course. Okay, sorry for that little glitch. I got this little line in the middle. I don't know how to get rid of it. Hold on a second. Well, apparently I can't get rid of it without starting over. So here's the deal. I'm going to go ahead and work with it. So, wonderful. Oh, it went away. There you go. All right, so here's the directions I'm going to follow right here to complete the square on the red stuff right here. So, number one, rearrange the terms to group the like terms. So I did that with my I don't knows. And then create open spaces for constants, and I did that. Complete the square for x values and keep the equation balanced. So here's how I do it. I do the negative b divided by 2a. So negative 10 divided by 2 is equal to negative 5. Now when I square negative 5, I get positive 25. And if I add it to the left, I better add it to the right. Now here on the y, I take the b term, same thing. Negative 6 divided by 2 gives me negative 3. I like to actually make the little square. So 3 squared is 9. And if I add 9 to one side, I better add it to the other. Now what I just did was create these perfect square trinomials. Now I just need to factor them. And this is why I do the square, because it gives me the terms there. X minus 5 quantity squared plus, don't forget to put that plus in, some people do, y minus 3 quantity squared. I'm seeing my value right there. Negative 25 plus 25 is nothing, plus 9 is 9. So here's my equation. X minus 5 quantity squared plus y minus 3 quantity squared is 9. So the center is 5, 3. The radius is 3, not 9, it's 3. Okay, so here's the directions out for that if you need it. And now let's look at this one a little bit more technical. I'm going to complete the square for this. And I know that you're probably thinking that I can divide 4 out of everything, and I really can here. But I just want to show you the process. So let's do it, and I've written the directions right here for you. And let's get started. Number one, group the like variables together and isolate the constant. So I'm going to say 4x squared plus 12x plus the I don't know plus 4y squared minus 24y plus the big blank is equal to negative 41. Now divide the coefficient of the squared terms, and the coefficient is a 4. Today it's a 4. Sometimes you'll have all different numbers, but whatever is the coefficient of the x will be the same coefficient with the y, and you'll divide that out and leave it to the left. So in other words, I'm going to divide 4, factor 4 out of everything here, and I'm left with x squared plus 3x plus y squared minus 6y. And notice I did not factor it out of the right. So I'm going to do that. I'm not factoring it out of the right. So now I'm going to complete the square, and I've done the steps here for you. Let me change to red because I'm moving into that. Complete the square by taking your b term and dividing it by 2. So 3 halves. 3 divided by 2 is going to be 1.5, correct? And then 1.5 squared is going to be 2.25, I think. I hope. All right, and then here, negative 6 divided by 2 gives me negative 3. Negative 3 squared gives me positive 9. Now here's the deal. I added 2.25. Notice I did not add 2.25 here because that's not actually what I'm adding. When I add 2.25, I had to multiply it by 4. I'm actually adding 9. So add 9 to this side. 2.24 times 4 is 9. Here, I didn't really add 9. I added 36, right? Because 9 times 4. So I better add 36 to this side. And now I'm going to, and I've done these steps 3 and 4. Now I'm going to divide, complete the square. Oh, I forgot to say to, what do you call it? Factor my perfect square trinomials. So add that step. So this becomes x plus 1.5 quantity squared plus y minus 3 quantity squared is equal to, and this side is going to be 40 and negative 41 is going to be 4, right? So here is my real equation. I have 4 times this equals 4. You have to make the x, the coefficient of the x and the y is supposed to be 1. So you have to get that 4 out of there. So you divide both sides by it. It goes away on this side, right? And if you divide both sides by 4, it becomes a 1. So your equation is now x plus 1.5 quantity squared plus y minus 3 quantity squared is equal to 1. Your center is negative 1.5, positive 3, and your radius is 1 because the square root of 1 is 1. Okay, I added that factor your perfect square trinomials and divide. So I added that last step. Oh, the fan is cutting on for this because it's running hot and it's still a long video. Hold on. The only thing I have left to show you about this is finding the x and y intercepts. Here, when you do that, all you do, if you're looking for the y-intercepts, you turn the x to 0 and solve. To find the x-intercepts, you turn the y to 0 and solve. We are at 12 minutes. You guys take care. Bye.